Welcome back, young math Padawans. In this part 2 video, we're going to be going over the examples of solving equations, making sure that we're using the properties of quality correctly, and maybe even in a different order than when you were taught. So grab those notes and let's go. All right, for our first example, you're going to write down 2x plus 5 equals negative 3. And so that we keep these in mind, I went ahead and put all of our properties of quality on the left-hand side of the board so that we can actually try something, right? So there's a couple things that we could do here, but which one makes the most sense to do first? So the first thing I like to do actually is I like to draw a line down the middle of my equal sign, because I want to make sure that I'm separating the left side of the equal sign from the right side, and also making sure that I'm doing these operations to both sides of the equation equally. The next thing I do is I ask myself, what's actually happening on that other side? So I see multiplication and I see addition. So already I'm thinking to myself, okay, I'm probably going to have to create a 1 out of the 2, and I'm going to have to make a 0 term out of the 5. So already in my head, I have this idea of like, I'm going to have to make a big 1 factor and I'm going to have to make a 0 term. But which one should I do first? Well, when in doubt, just try something. So let's say I want to make a big 1 first. I want to get rid of that 2. Well, how do I do that? To make a big 1 out of 2, I have to divide. So you think to yourself, okay, I'm going to divide both sides by 2. But hold on, what does the division property of equality state? You have to divide all terms, meaning you also have to divide the 5 by 2. So then, yeah, that's great. It gets rid of this 2, but now I have to do 5 divided by 2 and negative 3 divided by 2. And because those aren't divisible by 2, now I'm going to have to deal with fractions, which, by the way, still works. But most of us don't really like dealing with fractions, so I don't think division is the right idea. Multiplication won't help us either, because multiplication is just going to make everything bigger. And if I try to add something on both sides, this term's just going to get bigger. So by process of elimination, that leaves us with one option. Let's subtract. Let's make 5 a 0 term. So to do that, I'm going to subtract 5. And because of the subtraction property of equality, I'm doing it on both sides. Now watch, I don't cross things out, right? This is not a canceled thing. 5 became 0. So I'm writing a 0 placeholder here just to remind myself that's what happened. My equation became 2x plus 0 equals negative 3 minus 5. Now let's simplify. So 2x plus 0 just leaves us with 2x. And negative 3 minus 5 is negative 8. Are we done here? No. In fact, this is called a two-step equation because it's going to take 2 properties of equality for me to solve. All right, well, now I'm left with multiplication. So I'm thinking to myself, I'm probably not going to add or subtract. I don't want to make a 0 here. I want to make a big 1. So am I going to multiply or am I going to divide? Well, if I chose to multiply, let's say I multiplied both sides by 2, then this became 4x. And I feel like that's not getting me any closer to getting x by itself. So that didn't work. Let's try dividing, see what happens there. Okay, let's say I divide both sides by 2. What does that do? Well, 2 divided by 2, that's a big 1. And again, I didn't just cross it out. We're writing in what it actually means. 2 divided by 2 is 1, and 1 times x gave me x by itself. So already I'm feeling pretty good about that. Let's see what happened on the other side. Negative 8 divided by 2, negative divided by a positive. Think about math there, right? A negative divided by a positive, a negative 4. Now, even though I feel like my work looks really good and, you know, I used my subtraction property of equality and my division property of equality, I'm still not sure that this is correct until I do an actual check. So now let's check by plugging in negative 4 for x in the original equation. And the check is the most important step here because this tells you whether or not you did everything right. So here we go. 2 times negative 4 plus 5, does that equal negative 3? Well, by order of operations, we do parentheses first, which I don't see any. Exponents, I don't see any, but we do multiplication before addition. So I'm going to multiply 2 times 4, which is negative 8. Plus 5. Does that equal negative 3? Well, let's see. Negative 8 plus 5 is negative 3. And negative 3 equals -3, which means -4 was our correct solution. Okay, example 2, x divided by 2 minus 6 equals -1. We're going to solve using our properties of equality by creating big one factors in zero terms. First thing again that I like to do is put an equation on the middle of my equal sign so that I'm keeping both sides of my equation separate. All right, let's try something. So the first thing I notice is that I do see some division, which means I'm probably going to have to make a big one. And I see some subtraction, which means I'm probably going to have to make a zero term. Now here's the thing. A lot of us are really uncomfortable by that fraction bar. It makes us really uncomfortable. We don't like it. So we oftentimes choose to get rid of it first. But here's the thing. If I choose to multiply, right, because it is division, so to make a big one, I have to multiply it. Can I just multiply on both sides like this? Well, let's look at the multiplication property of equality. It says multiply all terms on both sides of the equation by the same value. Did I multiply everything? No, I forgot to multiply 6 by 2. So if I chose to multiply first, the most common error is to forget that you have to multiply all terms. And then I could multiply the 6 by 2, and that would give me, let's see, this would be a big one factor. And I would have x minus 12, not 6, because this was also multiplied by 2, equals -2. And then what can I do from here? Now that I have subtraction, I no longer care about making a big one. I want to make a zero term. I want to get rid of this term. Am I going to subtract 12? Well, no. Remember, we're thinking about this as a negative. So to make a 0 out of a -12, I need to add 12 to both sides, right? That's our addition property of equality. And I'm showing what this is. This is not being crossed out. It's not canceled. It became 0. And x minus 0 is just x. And -2 plus 12 is 10. So if I chose to multiply first and add second, I would get x equals 10. Before we do the check though, I'm going to solve this again using a different order of steps just to make sure that I'm still going to get the answer of 10. So same equation, but what happens if instead of deciding to multiply first, I chose to add first? So again, line down the middle of my equal sign. I'm going to get rid of the 6 first instead of getting rid of the divided by 2. So to do that, I already know I'm going to add 6 to both sides because that's my addition property of equality. -6 plus 6 is 0, right? We created a zero term. We didn't just cancel anything out. That word doesn't exist. And we have x divided by 2 left over on the left side, equal sign on the line. -1 plus 6 is just 6 minus 1, which is 5. Now, again, we can get rid of the divided by 2. So to do that, we're going to make a big one factor. How do you make a big one if you already have 2 in the denominator? Easy. Just put 2 in the numerator with multiplication property of equality. That creates a big one. 1 times x is just x by itself. And again, we ended up with x equals 10. So did it matter the order of steps that we did? No. When we multiplied first, we got x equals 10. And when we added first, we got x equals 10. So you have more options than you think, as long as you're using the properties of equality correctly. Let's check it. My check symbol. All right, substituting in 10, 10 divided by 2, minus 6. Does that equal -1? It's a question mark. I don't know, does it? 10 divided by 2 is 5. Does that equal -1? Well, let's see. 5 minus 6 is -1, which means that 10 made the equation true, and 10 is our solution. All right, example 3, 2/3 x equals 10. Now, most of us will come to this and go, it has a fraction, which means I can't do it and it's too hard and I don't want to, right? Fractions are actually easier than you think. Remember what we did in our warm-up, how we treated the fraction as multiplication and division? That's all it is. Consider an equation with a fraction just a 2-step equation. We have to deal with the multiplication and deal with the division. Now, there's 2 ways to do this. There's the longer way and there's the shorter way. I'm going to show you both. For the longer way, the first thing we're going to do is we're going to rewrite this so that we feel a little bit more comfortable with it. Instead of 2/3 times x, we're going to change this to 2 times x, all divided by 3. We're going to basically multiply, move that x into the numerator, and turn this fraction into a quotient. Now, why do we do that? We do that because we already know how to handle a quotient. If there wasn't anything up here in the numerator, you know how to make a big 1 out of a divided by 3. How do I make a big 1 out of a divided by 3? I'm just going to multiply, because multiplying will put a 3 in the numerator and a 3 in the numerator and a 3 in the denominator. That's just a big 1. So the first thing I'm doing is I'm really just kind of dealing with the fraction part. I'm getting rid of this denominator. I'm turning it into a big 1, and that'll just leave me with 2x on the left side equals, and then again, because of the multiplication property of equality, other side is now 30. Now I'm not done, but if you notice, I've now gotten rid of the fraction piece. I'm in a way simpler equation to deal with. 2x equals 30. I'm going to make a big 1 out of the 2 because it's a product. And to do that, this time I'm going to divide both sides by 2 using our division property of equality. 2 divided by 2, that's just 1, a big 1. And 1 times x, again, leaves us with x. 30 divided by 2 is 15. So again, all we did was we moved x into the numerator. You're multiplying by the numerator, dividing by the denominator. We changed it into a quotient. We multiplied both sides by the denominator to create that big 1. That left us with 2x equals 30. And then we divided both sides by 2 to end up with x equals 15. Now that is the long way. Let's look at a different way now that makes it a little bit shorter. Okay, method 2, 2/3 x equals 10. Again, I'm going to start by putting my line down the middle of my equal sign. Now again, I'm looking at this still in a similar way as multiplying by 2 and dividing by 3. But in other words, I want to try to make a big 1 out of the whole fraction 2/3. Well, to do that, I could actually multiply it by something and it would equal 1. Well, let's think about this. We already have a 3 in the numerator, or excuse me, in the denominator. So what if I put a 3 in the numerator? That would create a big 1. And we already have a 2 in the numerator. So what if I put a 2 in the denominator? That would also make a big 1. What do we call this fraction where it's kind of like the flipped, the opposite, or what word is that? It's called the reciprocal. All we did was we multiplied by the reciprocal of the fraction, and that made a 3/3, which is a big 1, and a 2/2, which is a big 1. So we're also going to do the same thing over here, multiply by the reciprocal. Now what's actually happening is 2 divided by 2 is a big 1, 3 divided by 3 is a big 1, and you're left with 1 times x, which is just x by itself. Now over here, again, multiplying by a fraction is easier than you think. It's just multiplication and division. This is just 10 times 3, then divided by 2. Well, 10 times 3 is 30. 30 divided by 2, 15. Look at that. We ended up with the same answer that we got originally. Let's go ahead and check it now. We always do our checks. 2/3 times 15. Does that equal 10? Let's see. Remember, multiplying by a fraction is just multiplication and division. That's 2 times 15 divided by 3. Does that equal 10? Well, 2 times 15 is 30. 30 divided by 3 is 10. So yes, 15 is our final solution. On to our final example. -4 plus 2x equals 10. Now, for this one, I'm going to have you do this on your own first. So go ahead and pause the video now. Let's go over it. Okay, first step, draw a line down the middle of your equal sign. Now, what I'm seeing is I'm seeing some addition, which means I'm probably going to have to make a 0 term. And I'm seeing multiplication, which means I'm going to have to make a big 1 factor. So a lot of us want to get rid of that 2 from the x first. So let's see if it works. How do I get rid of a 2? Well, how do I make a big 1 out of a 2x? I'm going to have to divide by 2. Let's see. Now, again, that means I'm using the division property of equality. And what does it say to do? Divide all terms, which means I also have to divide the -4 by 2. And if I did that, this would make a big 1. And I'd be left with -2, because that's what -4 divided by 2 is, plus x equals 5. And from there, I could continue to solve. Now, I'm going to guess that many of you chose not to do it that way. So I'm actually going to solve it the other way instead. And then that way you'll be able to compare your work to my work a little bit easier. So again, the equation was -4 plus 2x equals 10. Let's say instead of dividing first, you chose to make a zero term first. Now here's where the error comes in. You see addition, and if you haven't been paying attention, you're gonna say, oh, the inverse of addition is subtraction. So I'm gonna subtract 4 from both sides. And when you went to check, for those of you that did, chances are your answer was wrong. Here's why. What's negative 4 minus 4? That would mean that my equation just became negative 8 plus 2x equals 6. Now, that's okay, but am I any closer to solving? No, I'm trying to get x by itself. I'm not trying to make it more complicated, right? So instead of subtracting just because you see addition, go back to what we're trying to do. We're trying to make that term a 0. How do I make a negative 4 into 0? I'm going to add 4. Yeah, I know it sounds weird, but that's the only way that you can make a 0 term. Negative 4 plus 4 is 0. And then I'm left with 2x equals 14. Now I can make my big one. So to make a big one, I'm going to divide by 2, because 2 divided by 2 is 1. And 1 times x gives me x by itself. And I end up with x equals 7. Let's check. All right, negative 4 plus 2 times 7 equals 10, question mark. We don't know. Now remember, order of operations, which comes first, addition or multiplication? Pretty sure in PEMDAS or GEMDAS, the comes before the right? So we're going to multiply before we add. So this becomes negative 4 plus 14. And negative 4 plus 14 is 10. And that's how we could solve example 4. All right, good job, young Padawans. You've made it through part 2 of the lesson. Remember, there's no such thing as canceling. It's either you're making a 0 term or you're making a big 1 factor. And your work should show that. Don't just cross something out. Either draw in a 0 or draw in a big 1. It'll make your thinking a lot easier. Also, when in doubt, just try something. You only have 4 options: add, subtract, multiply, or divide. And as long as you're using the properties of equality correctly, you can't go wrong. Great job today. See you next time.